Next, we have an exciting session by Ayan Bhadury, a software engineer at Grafana. Ayan is an expert in observability tools and is here to share his insights on how to monitor and analyze complex AI environments effectively. Ayan will be presenting on enhancing observability with OpenTelemetry and Grafana. In this session, he will walk us through the fundamentals of OpenTelemetry and its integration with Grafana, providing practical steps to set up OpenTelemetry instrumentation and using Grafana dashboards for observability in AI and SRE environments. Please join me welcoming Ayan Badru to the stage.
Thank you. Hi, everyone. A lot of talks happened already, right? So we got to know a lot about OpenTelemetry being talked about and how it is impacting the current observability market. So today's talk would be about OpenTelemetry and Grafana, like how Grafana is making sure like it has all the tools and configurations available so that it is 100% OpenTelemetry compatible so that you can use OpenTelemetry and visualize all your data like metrics, logs, and traces in Grafana. So before we start, a bit about myself. I am actually a CX engineer at Grafana Labs. I mostly interact with the end customers, creating solutions for them, debugging their technical issues, figuring out their configurations, like in case they face any production issues. Today's agenda would be mostly about the OpenTelemetry, how OpenTelemetry is impacting our lives and how it like reduces the complexity of visualizing our data, metrics, logs, and traces. Then when OpenTelemetry was actually launched, it was mostly discussed in terms of traces, right? But we then OpenTelemetry evolved, and we now have all the three signals that can be visualized using OpenTelemetry: the metrics, logs, as well as traces. Now there are talks now coming up, profiles as well. So then we'll see some how OpenTelemetry can be configured in your applications, and we'll also see like what are the tips and tricks that you should maintain while creating the OpenTelemetry configurations, and how you can actually develop your SDKs so that those data are fetched properly. A quick poll. So I see a lot of brightest minds here. So anyone using OpenTelemetry already in your application, please raise your hand. Okay, so good to see like no one is using OpenTelemetry, but I think after this talk, it will gain some interest about what OpenTelemetry is. The other thing that I want to know, like you are actually, I think, using observability in some way on your applications, right? So I think you use to store metrics in one application, maybe logs in Fluentd, maybe traces in another Jaeger or other applications. Like it's a bit of hard to manage everything, right? All three fundamentals are being visualized in a different softwares. So it gets very hard to manage, and each of these platform has their own way of maintaining data and own way of protocols, right? You need to learn their own languages. For example, if you use a different software, you need to learn their query language. So those kind of things get very hard, right? So that's how OpenTelemetry eases all those things. And there is also the other caveat is like what language you're using the software, writing your software. Like your team could be, your backend team could be writing one software in Go or Python, or you're maybe in a front end, it is in the JavaScript or in React or in Angular. So how to collect those kind of data in a single platform and visualize those so that you don't have to like, you know, use a lot of other tools for each and every services, for front-end services, for the database services, or maybe for the back-end services. bit overview of what OpenTelemetry is. There are a lot of statements written. It's actually a collection of APIs, tools, and SDKs. So OpenTelemetry helps you to like collects your data, like metrics, logs, and traces, and it helps you to export you to a vendor where you can finally visualize those data. So it has got a lot of ways to ingest those data. You can actually write some SDKs, you can import some packages and just call some methods, and you are good to go. You can actually grab those data like the logs and the metrics from that applications is generating. Otherwise, you have something called as collector. We would be talking on that in the later stage, where you can actually collect all those data, process those, and finally export those to the vendor. Vendor, I mean the place where you would be visualizing your data. So this is a typical diagram, basic diagram, what the architecture of OpenTelemetry looks like. A very basic diagram. These are your applications, and then you have the collector, then you have the vendor. So applications are your program. Let's say you have a service which has backend database as well as front end. So these are all running. You can actually run a collector in the midway. So your backend data will finally send all these like the data to the collector. Then the collector has got three fundamental blocks, which is the receivers, and you have the processors, then you have the exporters. So the receivers are, by the term, it receives those data. Processors, I mean, it processes the data, like, for example, in case you have some like restricted data that you don't want those data to be publicly available. You want to pre-process those data, or maybe you want to add some more details on that data. Maybe add some attributes, like let's say this data belongs to this service, which is not coming up readily from the applications. You can use on those processor side. Then on the exporters, you decide like at which time series database or which storage platform those vendor will go. So that's the advantage of using OpenTelemetry, right? So if you see it right now, we just split this into vendor one and new vendor. So let's say I have an applications and I'm collecting the data into a collector. Now I have the flexibility. So OpenTelemetry has its own standard, and the vendors needs to follow those standards. So let's say let's say a team has actually purchased some observability tool, and without exploring much, and at the later stage they found out like it's the cost of that observability tool has increased, right? So it creates a lot of problem, and their backend team has already developed developed everything based on that observability tool. Now changing those everything requires a lot of effort, right? Now let's say we have this kind of a system where there would be a simple one universal protocol where you would collect all those data using that protocol. Then let's say you have visualized using some one vendor A, and you want to change from Grafana to, let's say, to another vendor at the later stage. You can simply do that using OpenTelemetry. You don't have to like rewrite everything again from the scratch. And the other example that I can think of is like, for example, for initial purpose, when you want to decide which observability tool you want to go for, you can actually do a comparison on that as well. Let's say you collect those data and you send those data to vendor A and vendor B, and you see like what are the performance improvements that you can see on vendor A and vendor B, and you can decide accordingly. So this is a bit of a diagram, like what used to happen in the few years back in the observability. We used to have a lot of like new standards coming up each and every day, and people used to get confused, people used to get confused that there would be another new standards that coming up, and we need to adapt accordingly, right? So that's what OpenTelemetry helps to reduce those kind of standards, and it creates an unified way to ingest those data and visualize at your vendor side. So right now, OpenTelemetry has got 700 plus integrations, and I just like to mention it's the second most active project in the CNCF community right now, next to Kubernetes. So you have the languages, right? I mentioned about the SDK. So you have a lot of languages support, for example, JavaScript, Go, Kotlin, C++, .NET. So everything, if you have those backend services already written, you just can import a single package of OpenTelemetry and you can get those data from those applications. On the component side, as I mentioned, you have the collectors, you have the exporters, processors for processing and receivers. There are other extensions and resource detectors as well. You can go to the OpenTelemetry registry to learn more about that. And the vendors. Like a lot of vendors are now OpenTelemetry compliant. AWS, Grafana, Datadog, Dynatrace, Elastic. So you have a lot of options. You are not stick to one vendor right now. Let's say you are using AWS and for some reason you want to switch to Elastic or maybe Grafana at the later stage, you are free to do that. So that's the reason why OpenTelemetry, right? It gives you the freedom to decide at which destination you want to send the data to, and it also reduces to switch the vendor cost as well. The standardization, so that it uses single standardized protocol to send those data. The open source, it's being actively worked on. People are actively contributing to the project, and development process are very transparent on that. And vendor support as well. As I mentioned, all the leading observability tool right now are supporting this OpenTelemetry protocol. What is now to Grafana, right? So we have few folks from our Grafana Labs team, our core fundamental members of the Grafana Labs team who are actively contributing to the OpenTelemetry project, from the Prometheus maintainer to the CNCF governing board as well. Now we have created a customized OTel collector, which is compatible with collecting the OpenTelemetry metrics that we call Grafana Alloy. It can capture those all of your data. It is like a few minutes back we showcased a collector diagram, right? It's the same thing. It's a collector that is developed by Grafana Alloy. It has got pre-built exporters and processors that helps you to like filters out the data according to your use case. We also have got an OTLP gateway. For example, let's say you do not want to run the collector. If you want from applications to directly send to your vendor the data, you can do that using the OTLP gateway. Then from the vendor, when you visualize your data in Grafana, maybe you have a requirement to store those data for a long-term storage, for persistent storage. So in those cases, you can use our time series database. We have, for traces, we have Tempo. For metrics, we have Mimir. Then we have logs for Loki. Then we have, it's not in the slides, we have Pyroscope for profiles, for performance-oriented data. So basically what these databases are, it's a time series database. It can handle billions of data. You can use Tempo for distributed tracing, Mimir for Prometheus metrics, then logs for Loki. You can aggregate those logs, showcase them, convert them into metrics, and create some alert rules, create incident management response, define the SLOs, and so on, once the data are in Grafana side. So this is the another architecture high-level diagram of what OpenTelemetry is. So basically, as I mentioned, so these are the SDKs, the microservices that are running, that sends the data in the OTLP format. You have the OpenTelemetry collector in the midway for processing and deciding where to send the data. Otherwise, if you do not want to use the OpenTelemetry collector, you can send this to the third-party services. Consider this as Grafana Alloy. Then if you want to, instrument your managed database or APIs, you can use that as well. Not only that, OpenTelemetry helps you to collect your Kubernetes related data, your cloud-related information, even your kernel information using eBPF. So those kind of exporters are available. You can send those data to the collector, and find from the collector, you can decide where you want to send those data, right? If you want to send this to a time series database, let's consider this, you can send this to a Prometheus database as well, or maybe to a Thanos database. So you can do that. For the hotel, you can send this to Traces, maybe to Jaeger, or maybe to our Tempo, and also to column stores like ClickHouse. You can also send those data to ClickHouse. So you have enormous possibilities where you want to send your data. This is the another diagram which highlights what OpenTelemetry collector is. As I mentioned, the OpenTelemetry collectors has the receivers. It can be in OTLP format, it can be in Jaeger format, or it can be in the Prometheus compatible format as well. Then you have the processors, which there are a couple of processors available, batch processors, which are actively used. There is attributes, you can actually sample them, like for example, let's say I want only data to available which has the 500 error code. So you can sample those in the processor sites. Then you have the exporters, where you can send this to Jaeger, Prometheus, Grafana, or to the other different vendors. Something about the semantic conventions. So for example, whenever a data is sent from a services to via the OpenTelemetry collector, it takes up a couple of attributes we called as. For example, it can, for example, if it is a network service, it will give you the information like client address, network type. In case it is an SDK, for example, Node.js, it will give you like the Node.js version, the package dependencies, and a lot of things. So there is a good example in the GitHub about OpenTelemetry. You can go ahead, and if you see the semantic conventions, all the service categorizations are mentioned there. You can learn what are the services attributes that you can get by default. Not only that, if you want some custom attributes, you can actually get that. A bit tabular representation of what exactly is happening right now with the various SDKs. So the traces is stable in C++, metrics and logs. For JavaScript, the logs is in development. For Go, it's still in beta. But mostly all of the things in traces and the metrics are stable side. So if you are using any of these applications already on your application, just try to use that, use OpenTelemetry, simply import a package. I think everything would be in the website. It has a very good explanation of how to use those. Just simply import those packages, and you would be able to visualize those data to any of your vendor that you are currently using. This is a use case where one of our customers, Sentry, was used our Grafana, and they have collected those data in the OpenTelemetry, and how they have reduced our cost. So what exactly happened is, like, they have the OpenTelemetry data. They finally send those data to our Grafana cloud, right? Now we have a cardinality analysis, and we have also got some adaptive observability tools like adaptive metrics, traces, and logs, where we check like what exactly your metrics. For example, in adaptive metrics, we see like which metrics are actively used and which are not actively used. For example, with OpenTelemetry, the problem is like you can ingest a lot of data and a lot of metrics, which can increase your billing right at the end stage if you ingest everything. So with adaptive metrics in Grafana, we know like which metrics are used in your dashboards actively and which are not being so used, and which has high cardinality levels. So using those, you can actually remove those and configure your OpenTelemetry collector accordingly, so that you do not need to ingest those metrics, because those are not actively used and those does not give any value. So that reduces the cost, right? So that's how Sentry was able to reduce those costs with Grafana Labs. So this was when a few years back what Grafana used to mean. Right now things have evolved. Now we have done a lot of things. Now you have your applications, then you have the collector, as I mentioned, the Alloy or the OpenTelemetry collector. You send your data to our Grafana stack, which is Loki for logs, Grafana for visualizations, Tempo for traces, and Mimir for metrics, and Pyroscope for profiles data. Once you have the data, you have the enormous opportunity to use those data and use to create incident management response, like create alerting if something goes wrong, send it to your PagerDuty or maybe Slack or maybe your SMS. You have the infra level observability where you can monitor how your Kubernetes cluster is monitoring, how your node is monitoring, how much cost is coming up on your Kubernetes cluster. Then you have the applications level monitoring, which we discussed. Then you have the performance and the load testing. For example, let's say you are in load testing, you are making an application live, right? And you want to know like how your API will perform when thousands or few lakh users will log into a single database, single API endpoint when they will hit it, whether it will crash or whether it will fail, what would be the HTTP response in those cases. So all those metrics you can get on the performance testing side. So using those, it will help you to ensure like whenever your application is released, it can handle those situations. Demo, I think I don't have much time, but I'll just give you an overview of what I meant here. In my earlier talk, it actually has, let's see, this is a diagram where we have a lot of front-end and back-end services, database services, which has all these gRPC and HTTP protocol, right? So those are all interconnected, right? Now, there could be customers, like there could be developers who have implemented several languages for a particular application. Some are written in Go, Java, .NET, some are written in Python as well. So all those things, even if they are written in different languages, you can actually use OpenTelemetry to collect those data, finally send it to your OpenTelemetry collector, and then send it to your the vendor, where you can visualize your metrics, logs, traces. And for example, let's say at particular date backend file, JS file, there are some issues and you want to see those, you can use the traces to view that file where the issue is. From there, there is a log section. You just click on the log section, it will go to the logs and it will show you what exactly the issue was. And from those logs, you can actually generate a matrix and see what is your rate of logs for a particular duration. So from traces to logs and logs to metrics, those intercorrelation can be done on once you ingest those data on the Grafana side. Kind of similar diagram, but with Linux, Kubernetes, and Postgres. As I mentioned, you can monitor those services as well. Yeah, I think I'm done, but just before that, I just want to mention like whether collector is actually you need to use every time or not. I mentioned a lot about collector, right? So if you know like how to monitor your collector configurations and you know how to manage your collector well, then only use collector. Otherwise, if you are having a simple applications where you need to grab those metrics, logs, and traces, I would recommend you to just simply use the SDKs, send those data directly to the vendor and visualize it. If you want to have much more your hands-on on how much data you want to send and which data you want to send, you want to have the advantage of processing those data, then only use those collectors. Otherwise, I would recommend you send those data directly. I think I'm 2 minutes left. I'll do a quick Q&A if anyone has questions, please.
Yeah, so you mentioned about the correlation between logs, traces, and metrics, right? And you said like we could able to go from traces to metrics to logs. So is that part of the vendor functionality or it's given by the OpenTelemetry itself?
Part of thing is OpenTelemetry provides, but it will be hard to configure. But if you use on the Grafana side, it's easier to maintain, because what we do is when you configure our a trace data source, you have the options in Grafana side to configure the logs as well. So whenever you select those trace now, there would be an option automatically coming on the Grafana side to select the logs, and you can generate the metrics from there as well.
Yeah, so in that case, if I understand correctly, all the information should be sent to one particular vendor, let's say like Grafana Cloud, And then only we can do the correlation.
Not likely because, for example, if you send it to Fluentd, the logs, and maybe the metrics are in Grafana in the Grafana side, so you can use Fluentd to fetch those data on the Grafana side and correlate them accordingly. So it depends based on your use case and scenarios.
It was something similar to that question only, but at the SDK side, would be able to apply some filtering logic, etc. Because I'm expecting around 1.5 million records per hour, and we are dumping data to BigQuery for processing and Looker Studio, etc. So something on the SDK side we can control from the source level.
You mean you want to filter out some
Yep,
data, right?
yep.
Yes, I think something can be done on the SDK side as well.
Okay, thank you.
But I would recommend you, if you have that amount of data, use a collector. And the other problem that I forgot to mention about collector is like you need to make sure the collector is highly available. Let's say your collector goes down for some reason, and all of your data are coming to collector, right? So if the collector goes down, then everything you're trying to visualize or observe that gets down as well. So you need to have another collector as well, and in front of that you need to have some load balancer, say maybe some Nginx or something. Okay, so that can help you on that.
Thank you, Ayan, for the fantastic session. Now let's welcome Ranjit Rajaram to hand over a token of appreciation.